Okay, now we wanted to we wanted y to go from 0 to 1, but there's a problem because from here to here, the limits are from the 1 minus x squared function over to 1, and from here to here, the limits are from the x squared function over to 1. So we have to split the region. Okay, so let's just draw it a little, so we have a reference over here. So we have this, we have this, we have our region, right? And here is y equal 1/2, right? So we have different functions limiting the region below the y equals 1/2 and above the y equals 1/2. Okay? So what we have to do is we have to say, okay, well, we're going to end up with two integrals, 0 less or equal to y less or equal to 1/2. And then x is going to go from 1 minus, okay. Here we have the 1 minus y squared function, right? So y is going to be the square root of 1 minus x, well, x minus 1. Okay?
Wait, no. It's, you got it backwards. It's 1 minus x squared equals y.
No, negative y squared will be x minus 1. Y squared will be 1 minus x. And if it was x minus 1, you'd have a negative under here for every possible value.
I'm talking about the original equation is 1 minus x squared equals y.
This?
Yes. Not 1 minus y squared equals x. You're right.
One minus y squared equals x. So x equals square root of 1 minus y. Sorry. Okay? I mean, the solution to the equation I wrote down there without thinking, obviously, was what I said it was, but that's not the equation relevant to the situation, right? Okay? So, on this, you're going to say that the square root of 1 minus y has to be less or equal to x, less or equal to 1, because no matter where you are, x is going to end over here at 1, right? Okay? And then you have and you just have square root of y. I mean, obviously it had to be y, but I wanted to make sure I wasn't doing anything completely stupid because I did right there, okay? Make sense? Going to give us two integrals, one for each set of limits, right? Now you know what those integrals are going to be. I'm not going to actually write them out, but now we know that we can do an area integral, and whatever we get from the sum of these two integrals, it better be the same as what we get from the integral corresponding to this, right? Okay? Make sense? Okay, well that's pretty straightforward. Okay. Now these things can get pretty complicated. You know, the thing with the quadratic zeros, it's wonderfully, beautifully complicated. Okay? So you got to get your feet wet on these things before you can actually solve that very simple programming problem. Okay? I came up with one, I came across one yesterday. I forget what it is. It was a different twist on it. And I just don't remember right off the top of my head. It's even more interesting. And I haven't worked it out yet, which is why I don't totally remember. I still have to generate those variables. Okay, well, anyhow. That kind of illustrates something. Now, what if you had an integral and you were asked to change the order of integration? I gave you a region and asked you to do it in 2 orders of integration, right? What if I gave you an integral, a definite integral with limits on the integrals and stuff like that? What would you do to reverse the order of integration?
You have to draw the region.
Yeah, you first determine what the region is. Determine what the functions are that bound the thing, and then do it in the opposite way, right? Okay, so I'm not going to illustrate that. I think you can get that, at least for 2 dimensions, okay? It'll come up in higher dimensions and in other coordinate systems, okay?